welcome back to the Azure Terraformer. Today we have another code review. A brave member of the audience has submitted some code to me for me to look at. So I'm going to look at it. I'm going to say what I like, what I don't like. I'm going to maybe refactor things a little bit based on my preference, and you decide. Do you like my changes? Do you like my recommendations? Anyways, let's go look at the code. So right off the bat, I can tell this is an AWS project. Looks like maybe it was built based off of a demo. That happens a lot. Like people take demo code and I guess people don't always start from scratch. But people take demo code and then they customize it for what they like to do. So right off the bat, I do like how it appears that this repository is going to have a place for application code and a place for infrastructure code, which we can see right here. I've got infra, and then I have my app code, whatever code this is. I don't know, was it TypeScript maybe? So it looks like we've got, and it's a static website. So this is probably like a TypeScript site. Where it's just going to be a static JavaScript based website that is hosted on AWS. So I do like that we have a place for infra code and we have a place for application code. Even if you're going to be leveraging shared infrastructure, like let's say a Kubernetes cluster or an app service plan on Azure or something like that, that isn't going to get deployed with your solution, or maybe like heavyweight services like Azure API Management or Cosmos DB, and those things get provisioned outside of your project. I think it is good to have a place for infrastructure code for your project, even if you're not provisioning traditional infrastructure, which I don't think is going to be the case here. We're not going to be provisioning VMs to host a static website. At least I don't think we are. But the same thing, like in Azure, if you're going to be deploying an Azure function, does it make sense to have an infrastructure code folder in your solution? What are you going to be doing with Terraform? Well, there will be some things that you'll want to deploy using with your Azure function, even though it's not like laying down the heavyweight infrastructure. The Azure function app itself, maybe some event grid subscriptions, maybe some containers into a shared Cosmos DB. Maybe some API definitions on API management, etc. Right? So there are some tangential things that may need to get deployed for your code, for your application code, even if you're using shared infrastructure. So I like that thought process right off the bat. This is the application specific infrastructure that's going to get added on to maybe some shared infrastructure elsewhere, deployed by other teams, for example. Or it could just be like everything. Like we just have a click button deploy where like all of our infrastructure gets deployed for this application. We're not using shared infrastructure, whatever. Either way you want to go, setting up your source code repository to have a folder for your Terraform code and a folder for your application source code where you can compile it and then keep it separate from the Terraform code. It's good stuff. So anyways, so I'm not going to look at the application code. I'm going to look at the Terraform code. And there's only one TF file, okay? So right off the bat, things that I don't like so much, well, okay, elephant in the room, he is using AWS. I have to say it. I mean, this is the Azure Terraformer. No offense, I'm just kidding. You can use AWS, no problem, like whatever. I do a lot of Azure. I work for Microsoft, so I do a lot of Azure on the site. So I'll look past this. Heck, my last code review was with somebody doing OpenStack. Okay, so I'm definitely, beggars can't be choosers. Let's put it that way. So I just had to throw it out there because it tickles me that I have yet to do a code review on my channel of actual Azure Terraform code. So so if you guys want me to review your Terraform code, Doesn't have to be Azure code. I'm just joking around. But if you do have Azure Terraform code, please send it my way. I'd love to review it and give you my feedback on how you've structured your Terraform, your HCL, code health, things like that, as well as what you're doing on Azure. I could review that as well. Probably a little bit better than I can do with AWS stuff. I can kind of fumble my way around in the dark with AWS and with OpenStack, but Azure is definitely my cloud du jour, as they would say. So anyways, what else is going on here? Well, let's go back to something I like. I like that he has set his required providers block. And we have, not the right provider. We have AWS, but there is a provider there, and we have a specific version that we're targeting, 4.63. Wonderful. You should absolutely do that. Even in the root module, you need to set your required providers block. Of course, then we have our provider block here as well. That's all fine. One thing I'm not too keen on is the backend is currently set in the Terraform code, in the HCL. I think it's good that you define that you are going to be using a backend and which backend you're going to use, but all of these parameters like the bucket, the key, the region, dynamo table, etc., I think these are best injected into your Terraform project by using an external mechanism, i.e. like a pipelining tool, or at the very least use like a local script that you've set up with these values to jam them in there when you run Terraform, using environment variables or whatever, bash, scripting to put these values in there. Don't hard code them in your code. Okay, even though it seems like I'm only going to be using this backend, don't hard code them in your code. Recognize that backend configuration is really a type of input variable, and it should be something that you inject into Terraform through the Terraform command line interface. So just throwing that out there. That's the first thing that popped out in my head. So a little bit of good, a little bit of bad in this Terraform block at the top. Next thing I notice, we're dealing with one file. One big ass main.tf. I would prefer to see this broken into multiple files. At the very least, on line 20 here, I see a variable being declared. There should be a variables.tf. Absolutely. You should have a consistent set of key files that you have within any Terraform project that you set up. The ones that I would say are absolutely required would be versions.tf, which is going to hold your Terraform and required providers block and any provider blocks that you set. You can optionally put that into a providers.tf, but which is what I used to do. But since the introduction of required providers, I just think it makes more sense just to dump everything into versions.tf. That way, you got your required providers block and you got your providers set up all in one place, because really they're very tightly coupled. They're very interrelated, these two things. The provider block, which basically initiates authentication and context with the cloud provider, and then the required providers block, which actually is more of an inward-looking Terraform thing of which version of the Terraform provider do I want to use, can I use, should I use, that sort of thing. And then the backend, again, is an inward-looking configuration setting for, where should I store the Terraform state. So all these things, I think, make perfect sense to go into one file, versions.tf. The next file you should have is variables.tf, which is where all of your input variables go. Every single variable should go in that file, no matter what. This will give you a nice contract and interface, definition for what do I need to pass into this Terraform thing to make it work. And this would apply to a root module and any reusable module that you develop as well. Absolutely. No ifs, ands, or buts. Input variables have to go in one big file. Lastly, I would say main.tf. You should have a main.tf. And I think the things that go into main.tf, if you're building a relatively small project or a relatively focused reusable module, maybe everything goes into main.tf. That can be a thing. That can happen. But definitely keystone type, I'm talking about keystone, like when you got a bridge and there's like that one stone in the middle of the bridge that's kind of oddly shaped, if you pull that stone out, like the whole bridge collapses, right? That's what I'm talking about. Keystone resources need to go into your main.tf. And so I think those types of resources make good sense because people are going to naturally, the first file that you're going to look at after you look at variables, maybe you might even skip variables, but the first file that you're going to really look at is main.tf. And so those keystone resources should be in main.tf, okay? Shouldn't have to go hunting around for them. And they should be at the very top of main.tf. I think location and file is also a, kind of code readability aspect of Terraform. Do you have your important resources defined at the top? Do you have related resources clustered together within the same file or split into their own file? And we'll get into that here in a little bit, I'm pretty sure. So main.tf. Lastly, you should absolutely have an outputs.tf. Are you always going to have output variables? No. Should you have an outputs file? Yes, just in case. It's a matter of convention, right? And I would argue there's probably always going to be at least one output variable that you're going to want. Even if it's just to spit something out for verification standpoint and say, yep, okay, that's the value. Let me go write that down. Let me go check and see what's getting put out into my environment. So those 4 files, versions.tf, variables.tf, main.tf, and outputs.tf should be the 4 files that you start every Terraform project with by convention. Now, that's my opinion. You can take it or leave it. It's a very common convention that I've seen used across many projects. Are there other conventions out there? Absolutely. And could you make up your own convention? Absolutely. Go nuts. Next, what do we have here? So we got some locals. We got some Route 53 stuff. We have an S3 bucket. We have a S3 bucket public access block. Okay. We got some more DNS stuff going on here. We have some Route 53 records, some more certification stuff, CloudFront, bunch of data references to CloudFront stuff, some more CloudFront, which links all that stuff together. And then we got some Route 53 way down here at the bottom, which is also dependent on CloudFront. Okay, because so we're linking the Route 53 stuff to the CloudFront stuff. And then we got IAM, and we have an S3 bucket policy. Oops, didn't mean to type that there. So, okay, so when I think of the outline of this solution, what are the things that come to mind? DNS, S3, CloudFront, and IAM. Those 4 things. If I just create broad stroke categories of the stuff, okay? And I would probably organize my files to group those things together. Because if you notice, like as I was going down this natural progression of random resources, I was kind of bouncing back and forth between like, oh, well, here's some CloudFront stuff, and then here's some S3 stuff, and then here's some more CloudFront stuff, and then here's some DNS stuff, and then here's some more CloudFront stuff. It's like, okay, that makes it difficult to read. So why don't we just like group all the CloudFront related stuff together, put it into a file called CloudFront, be done with it, right? Why don't we take all of our DNS related stuff, dump it into a file called DNS, be done with it. Let's take all my S3 stuff or my storage related stuff and just dump it into a file called storage.tf or s3.tf, whatever you want to call it, right? That will make things more readable. It'll also reduce the the lines of code in a single file. Like main.tf is 200 lines of code, right? There's a lot of crap going on here. So, in order to find and get kind of like a 50,000 foot view of what's going on in this project, I have to kind of like internally memorize like what's going on in this huge file. Whereas if I have those files broken up over here in my folder, I can see those key themes that are happening. S3, CloudFront, IAM. What am I missing? Am I missing something? DNS, DNS, right? And so just having a table of contents, right, is a huge win for our brains as humans, like to try and break down bigger problems into smaller problems. So let's just go ahead and do that and see what that would look like. So I'm going to blow out my file structure here.
A few moments later.
So I've got this. So the Route 53 stuff, I'm a little torn about what I'm going to do with this stuff. But some of these other things are a little bit more, makes like little easier decision here. So I got CloudFront, a bunch of CloudFront stuff. Yeah, let me just grab all the CloudFront stuff.
A few moments later.
And we got some S3 bucket policy hidden down away here. Let me just toss that over here. Now, this is linking to my IAM document. Okay. So that is kind of interesting. But it seems like this IAM policy is kind of like at the crossroads between two things, right? It's at the crossroads between CloudFront and S3, which is why it's difficult to put it in S3 or CloudFront. So I would just kind of slam it into this middle ground that I'll just call IAM, right? So if I go into CloudFront and I see a reference to IAM, it's like, okay, well, I know where that go. Well, I know where to go to get that stuff, right? IAM. Actually, it's not referenced in CloudFront, but it is referenced in here in S3, okay? So I've got this IAM policy document that I'm referencing, okay? Now, but I do have a special place where all the IAM stuff can go, and so I think it makes it a little easier to be like, oh, what's going on in my IAM policy, right? There it is. I can go look at my IAM file. Now, if I go look at main, really, I just have a bunch of like Route 53 and DNS related stuff, right? And it'd be hard to say, is this certificate, is this only referenced by, let's see where this is referenced. It's only referenced by CloudFront, really. So it's used by CloudFront one time. So it's not hugely important. I think it mostly is referenced by the DNS stuff, right? So if we go look at the DNS stuff, we got it's on the Route 53 record. It's on the but there is this ACM validation thing. So this ACM resource, I would probably move up and group it with the ACM certificate itself, right, to keep them all together. And you could kind of decide, do you want to have like a cert.tf, or do you want to have a DNS.tf? I'm just, let's just DNS.tf, and let me throw Route 53 in there. So I'm going to get all this stuff. This is all really DNS related stuff. And then what do I have left? I have a certificate. So, I mean, I could throw this cert into DNS, which it kind of is. It's hard to say. I think CloudFront's busy enough. We got enough stuff going on CloudFront. We got enough stuff going on in Route 53. I might just throw like a cert and throw my cert in that file, and there you go. You know, I got my cert. Now when I go to each file, I just have to process like two things. I get this ACM cert, and then I got a ACM cert validation. Parent-child. I can clearly see the parent-child relationship between these two resources. This is why I like breaking things up into separate files, so that I can see like inherently, immediately, as soon as I open the file, I can see the relationship between the stuff going on in there. Now, it gets a little out of hand, you know, when I got this CloudFront stuff. And it's hard for me to tell what the relationship is here, but I got this origin access control, which, this is like a prerequisite. So this is a little bit different than the cert. The cert was very clearly parent-child. What we got going on here is we have kind of configuration blocks. So this origin access control is really kind of it is a sub-resource, but it's kind of an inverted parent-child relationship in that this is really a sub-resource of this thing here, but it's instead of having the child reference the parent, you know, the parent is actually referencing the child, right? So, and I think all of that stuff is taking place here. All these, you know, policies, we're just attaching onto this default cache behavior, right? So again, we have kind of this inverted parent-child where the parent references the child rather than the child referencing the parent. But it's pretty clear to me that this CloudFront distribution resource is wearing the pants in the family, as it were. So I would probably put that resource first, because this is where the meat of this file is. It's in this CloudFront distribution, and then these little sub-resources are really just kind of fanning out from this main resource here. And they provide kind of additional flair or color to the conversation. So that's kind of how I would structure it. Most important thing first, which is clearly this CloudFront distribution thing. And then we have this origin access control, which is slightly more complex. And then we have these cache these policy things, which don't look important at all, right? So I would probably just throw that on there. Also, I would think about the naming here. Like, do these names down here add any value? Does repeating the resource type add any value? And what I would say, I just noticed this actually. What I would say in situations like this, what I try and do is I try and, rather than just repeat the name of the resource, I try and use that object reference for good, right? How can I add value? Well, is it possible I might have more than one cache policy? If that's the case, then, you know, having a cache policy called cache policy isn't super helpful, right? So what I'd probably want to do is I probably want to use the object reference to tie all these related items together so that we can see they're all related to the same thing. Again, distribution is an AWS CloudFront distribution. But what is this distribution for? Well, I mean, by the name of the site, it's a static website, right? So we could call this static website distribution, right? If we wanted to go like meta and be relative to this module, like we could just call this main if there's only going to be one, right? But let's just go a static website. Okay, so this is the AWS CloudFront distribution for static website. This is the origin access control for our static website. This is our cache policy for our static website. This is our origin request policy for our static website. This is our response header policy for our static website. And then what happens is, when you tie all these things together, it becomes less and less of a hunt and peck, right? Because, okay, which response headers policy was I going to use? I was going to use the one for static. Well, I'm on the static website, so I was going to use the static website's response headers policy. Likewise for the origin request policy and the cache policy. Now, I could even take this naming convention over to certificate. Think about it. Does this name, does this path to this object provide any value at all, right? It's the ACM certificate dot certificate. It, like, which certificate is it again? You know, doesn't make sense. So at least naming these things all static website, you know, they're all related. We all know that this is for the static website. If I go and expand this project to deploy a backend function, you know, that my static website's going to start using, right? I need a Lambda, right? Maybe that I also need to have that Lambda publicly available. You know, maybe there's going to be resources that are going to talk to that Lambda that that might use some of these same resources. Maybe I got a DNS, or I have a certificate for my Lambda function. Or the load balancer that sits in front of my Lambda function. I don't know. But this will make it so that you're not just using empty object references that repeat the data that's already embedded within the resource type's name. You're actually kind of creating utility in the object reference so that you can bundle all of these related resources together. So it'll make your code more readable and more manageable, because you'll know, okay, when I'm in the CloudFront distribution for the static website, all of these things, you know, I'm using the same object reference which is called site website. Static website. My bad. I'm using the static website reference for all the things, right? And I'm using the static website reference for all the things. So it becomes less about, you know, knowing the obscure variable name that you called it, foo or foo2 or foo3, and knowing, okay, what resource am I on? What are the dependent resources related to this resource? And they're all kind of named the same thing. They've got different types, so we can easily link them all together. So that's kind of the thought process behind that. And so anyway, what am I left in main? Nothing. Well, what happens in main? It becomes, you know, extra, you know, comments. You know, just throw some comments in main that you know, might point people to, you know, to the primary resources that they want to go look in, right? That's it. You could probably look at this code and try and think of what the keystone resource is, but it seems to me that most of the stuff has its own place, and is significant enough that it could be bundled together in its own little file. So, anyways, that was fun. Did a little bit of AWS code reviewing. Haven't done that in at least a year. Been at Microsoft for just over a year now. So have not been doing a lot of AWS since then. This just shows that if you know Terraform, you can apply those same principles across any cloud. And that's one of the powerful features of Terraform and HCL, is that these design principles, the way you organize things, the way you structure things, the mechanics of the platform transcend the particular cloud that you're using. And so it makes it much more easier to change horses, and to also use, you know, to automate other platforms. It doesn't have to be one of the hyperscalers, but it could be like a network switch or a database or something like that. So yeah. Anyways, I hope you liked this video. I hope you found it useful. Do you agree with all of my comments and all my feedback? Do you like what I did? Do you hate it? What do you like? What do you hate? Tell me in the comments below. I'd love to hear from you. And maybe I'll learn something too. Anyways, if you like this video, please smash the like button. If you're new to my channel, please subscribe and ring that bell when you do, so you know when my next video drops. And if you are using Terraform on Azure, please send me your code. I would love to review your code, just like I did with my internet stranger friend here who was brave enough to send me their AWS project. I'd love to look at your code. I'd love to review it. I'd love to make a video out of it. and share it back with you. And, maybe we'll both learn something from each other. So by all means, send me that GitHub link, send me that repo, make sure it's public so I can clone it. I'd love to do that for you. Anyways, that's it for me today. This is the Azure Terraformer signing off.